morning, all of you. In this session, I am going to explain about this spheres problem, and also I will explain how to convert this given diagram into free body diagram. I will explain clearly. Before going to the problems, first of all, you have to know the fundamentals about free body diagrams. From Newton's third law of motion, already we know that every action there is equal and opposite reaction. So here let's consider a horizontal surface and a roller or a sphere of self-weight W placed on a horizontal smooth plane. Okay. Then how to convert this diagram into forces diagram? First of all, you have to consider a self-weight W, self-weight of a body. Okay. According to Newton, self-weight always acts vertically downwards. Okay, this is the action. Okay, self-weight of any body always act vertically downwards. Okay. Now we have to consider a opposing force. Okay, here there is a contact between this sphere and the horizontal plane. Okay, at the point of contact, you have to consider a reaction force R. Okay, here the support is horizontal. You have to consider a perpendicular or normal reaction force. Okay, reaction force always makes an angle 90 degrees with respect to support. Okay, here the support is horizontal, so the reaction force is perpendicular to the support. Okay, the angle between support and the reaction force is always 90 degrees. Okay, now these are the two forces acting on the given point. Okay, now this is a reference horizontal line, this is a vertical self-weight, and this is a reaction force R. Okay, this is the free body diagram for this condition. Okay, in similar way, if you are considering a vertical support, okay, then how to convert this this self-weight and reaction force for this condition? First of all, you have to consider a self-weight W vertically downwards. Okay, self-weight of any body always acts vertically downwards. Okay, now there is a contact between the block and vertical wall. Here the support is vertical. Okay, here the support is vertical wall. So you have to consider a horizontal reaction force. Reaction force always makes an angle 90 degrees with respect to support. Okay, it is very important. Now you have to convert these two forces as a free body diagram. This one is a horizontal reference line, this one is a vertical reference line. Okay, now you have to consider this self-weight on vertical reference line, and you have to draw this reaction force on horizontal reference line. Okay, this is the free body diagram for this problem. Okay, always you have to remember reaction force always makes an angle 90 degrees with respect to support. Okay, here the support is vertical, so you have to consider horizontal reaction. Okay, in third case, let's consider a inclined plane. Okay, this inclined plane makes an angle theta with respect to horizontal. Okay, now this is the block of weight W. Okay, now how to convert this diagram into free body diagram? First of all, you have to consider this self-weight W. Okay, so self-weight of any body always acts vertically downwards, so you have to draw a vertical force W. Okay, here the support is inclined with respect to the horizontal plane. Okay, so this support makes an angle theta with respect to horizontal. Okay, So already we know that reaction force always makes an angle 90 degrees with respect to support. So you have to consider a perpendicular line perpendicular to the given inclined plane. Okay. So this reaction force makes an angle 90 degrees with respect to the support. Okay. Yeah, this is a self weight W. Okay, this is a reaction force R. Okay, from this diagram you can observe from triangle. You can observe this is a triangle. Here the angle is theta with respect to horizontal. So here also angle theta with respect to horizontal. Sorry, sorry. Uh, Here the angle is theta with respect to horizontal. So here also angle is theta. Okay, with respect to horizontal. Now from this diagram you can observe here the angle between this reaction force and this horizontal reference line is 90 minus theta. 90 minus theta. Okay. Okay. Then the angle between this reaction force and the vertical plane is theta. Okay. Okay. Here you can observe the angle between reaction force and the horizontal support is 90 minus theta. Then the angle between vertical reference line and the reaction force is theta. Okay. So the total angle is 90 degrees. Okay. So reaction force always makes an angle theta with respect to the vertical axis. Okay. So this is the free body diagram for this condition. Okay. For solving any problem, okay, you have to use these fundamentals for considering the reaction forces. Okay. So these are the important sign conversions. For right side direction, you have to consider positive sign. For left side direction, you have to consider negative sign. For upward direction, you have to consider positive sign. For downward direction, you have to consider negative sign. Okay, these are the important sign conversions for solving the problem. Now, this is a Lamy's theorem. So, Lamy's theorem also very important exam point of view. Let P, Q, and S are the three concurrent coplanar concurrent forces. Okay. So alpha is the angle between P and Q forces, and beta is the angle between force Q and S, and gamma is the angle between the force S and P. Okay. Now from Lamy's statement, the each force is directly proportional to the sine of the angle between other two forces. Okay. Here alpha is the angle between these two forces, and beta is the angle between these two forces, and gamma is the angle between these two forces. Okay. So from sine rule, you can observe force divided by sine of the angle between other two forces. So here P is the force divided by sine of angle between other two forces. Okay, here the angle between other two forces is beta, so P by sine beta. In similar way, Q force is the Q. Okay, and the angle between other two forces is gamma, so Q divided by sine gamma. In similar way, S is the force. Okay, so the angle between other two forces is alpha, so S divided by sine alpha. Okay, this is the Lamy's equation. So this Lamy's equation is applicable for three concurrent coplanar forces only. Okay, for three forces, okay, you have to use Lamy's theorem. Okay, now this is the given question. Okay, two smooth spheres, each of weight 1000 newtons and radius 20 centimeters, rest in a horizontal channel of width 85 centimeters, and a third cylinder of weight 2000 newtons and radius 25 centimeters rests on two cylinders as shown in figure. Then determine the reactions at the points of contact. Okay, this is the given question and this is a given diagram. Okay, two spheres or two cylinders, each of weight 1000 newtons and radius 20 centimeters, rest in a horizontal channel. Okay, horizontal channel of width 85 centimeters. Okay, and a third cylinder of weight 2000 newtons and radius 25 centimeters rests on two cylinders as shown in figure. Okay, determine the reactions at the point of contact. Okay, so first of all you have to convert this given diagram into forces diagram. Okay, so this is a given horizontal channel and this is a vertical support, this one also a vertical support. Now you have to consider these two cylinders as this. Okay, now this is a third cylinder. First of all, you have to consider a reaction force. Okay, always you have to consider a reaction force at the point of contact. Okay, here you can observe from the given diagram 1, 2, 3, 4, 5, 6. Okay, there are 6 contact points. Okay, 1, 2, 3, 4, 5, 6. There are 6 contact points. So you have to consider 6 reaction forces. Okay, so reaction force here. This one center A. This one is the self weight of a cylinder A. Okay, 1000 newtons is the self weight of a bottom cylinder. And this one is the reaction force. Here the support is vertical. Okay, the support is vertical, so you have to consider a horizontal reaction. Okay, the angle between this support and reaction is 90 degrees. Okay, here you can observe, so the angle between this reaction force and this support is 90 degrees. Okay, in similar way you have to consider a reaction force at bottom. Here the support is horizontal, so you have to consider a vertical reaction. Okay, in similar way for this cylinder you have to consider a self weight W equal to 1000 newtons, and there is 2 contact points here and here. You have to consider a reaction R3, horizontal reaction force. Okay, here the support is vertical, so you have to consider a horizontal reaction. In similar way, here there is a horizontal support, so you have to consider a vertical reaction. Okay, R1, R2, R3, R4, 4 reaction forces. Here and here you can observe there are 2 contact points and these 2 surfaces are movable. These 2 surfaces are also movable. So you have to consider 2 equal and opposite reactions. Okay. Now for this cylinder, you have to consider a self weight W equal to 2000 newtons vertically downwards. Self weight always acts vertically downwards. Okay, self weight of any body always acts vertically downwards. Okay, now here there is a contact between these 2 movable surfaces. So you have to consider two equal and opposite reaction forces at this point. Okay, for mobile surfaces. Okay, for mobile surfaces, you have to consider two equal and opposite reactions. Okay, for this cylinder, you have to consider downward reaction force. For this cylinder, you have to consider upward reaction force. Okay, both are equal and opposite. Okay, in similar way, here also there is a contact between these two surfaces. These two surfaces are also mobile surfaces. So you have to consider a reaction force R5. Okay, this R5 force, reaction force also equal and opposite. Okay, so here for this cylinder, you have to consider downward reaction. For this cylinder, you have to consider upward reaction. Okay, so there are 6 contact points. So I consider 6 reactions: R1, R2, R3, R4, R5, R6. Okay, here I consider 6 reaction forces. Okay, 6 reaction forces for 6 contact points. Okay, and 3 self weights. Okay, W equal to 1000 newtons for cylinder A, W equal to 1000 newtons for cylinder B, W equal to 2000 for cylinder C. Okay, so this is the complete free body diagram for this given diagram. Okay, here I converted this given diagram into free body diagram. Okay, for determining the value of reaction forces, you have to convert this figure into 3 cases. In first case, you have to consider this upper cylinder. In second case, you have to consider this left side cylinder. In third case, you have to consider this right side cylinder. Okay. Here the angle is theta. Here you can observe reaction force R5 and R6 makes an angle theta with respect to horizontal. So first of all, you have to determine the angle of inclination of the reaction force R5 and R6. Okay. So from you can observe from this triangle ABC. Okay, from triangle ABC, you have to determine the angle of inclination of the reaction force with respect to horizontal. Okay. Okay. This is a given diagram. Okay. Here you have to join each center like this. Okay. ABC is a triangle, isosceles triangle. Okay. Now you can from given question, the width of the horizontal channel is 85. Okay, the width of this horizontal channel is 85 centimeters, and also the radius of this cylinder is 20 centimeters, and the radius of cylinder B is also 20 centimeters, and the radius of cylinder C is 25 centimeters. Okay, so from this diagram you can observe the distance between center to the outer surface is radius. So here the distance is 20 radius, and here also the distance is radius. Okay, now the remaining distance is 85 minus 20 minus 20, that means 45 centimeters. Okay, the remaining distance is 45 centimeters. This 45 centimeters is equal to length of a line AB. Okay, now for determining the angle of inclination theta, you have to consider this triangle as it is. Okay, from this diagram, the length of this AB line is 45 centimeters. Okay, now this is a isosceles triangle. Okay, so here the base is to 22.5 centimeters and 22.5 centimeters. Okay, now from this diagram you can observe the distance, the length of a line AC, the length of the line AC is equal to radius of a cylinder A plus radius of a cylinder C. The radius of a cylinder A is 20 and the radius of a cylinder C is 25. So 20 plus 25 is equal to 45. Okay, 20 centimeters is the radius of a bottom cylinder and 25 centimeters is the radius of a cylinder C. Okay, so AC is equal to 45 centimeters. In similar way, the length of this line BC also 25 plus 20. That one also 45 centimeters. So this triangle is a isosceles triangle. So here you can observe uh, from this triangle ACD and BCD both are equal. Okay, from this diagram you can observe these two triangles are equal. Okay, triangle ACD equal to triangle BCD because two sides are equal. Here the bottom base is 22.5. Here also the bottom base is 22.5, and this slant side is 45 centimeters. This slant side also 45 centimeters. So these two triangles are equal. So take any triangle. Take any triangle for determining the value of theta. Here I consider this triangle ACD. From triangle ACD, this one is adjacent side, this one is hypotenuse. So from triangle ACD, cos theta equal to adjacent side AD divided by hypotenuse AC. AD equal to 22.5 and hypotenuse equal to 45. Okay. From this equation, the angle theta equal to 60 degrees. Okay. So the angle of inclination of the reaction force R5 and R6 is theta. Theta equal to 60 degrees. Okay. Now let's consider a free body diagram of a upper cylinder C. Okay. So first of all, you have to consider this upper cylinder as case 1. Okay. First of all, you have to convert this given problem into 3 problems. In first case, you have to consider this cylinder. Okay. In second case, you have to consider this cylinder. In third case, you have to consider this cylinder. Okay. So from top cylinder, you have to consider these 3 forces as this. Okay. Here I consider this cylinder C, free body diagram of a cylinder C. From this cylinder, you can observe theta. Theta is the angle of inclination of the reaction force R6 and R5. Theta equal to 60 degrees. Now you have to convert these 3 forces like this. Now you have to calculate the angle between 2 forces. Okay. Here the angle is theta, so and the angle is 90 degrees, 90 plus theta. Okay, here the angle between W and R5 is 90 plus theta. In similar way, the angle between reaction force R6 and W is 90 plus theta. And the angle between reaction force R5 and R6 is 180 minus theta minus theta. 180 minus 2 theta is the angle between these two reactions. Okay. So angle between the force R5 and R6 is 180 minus 2 theta equal to 60 degrees. Theta equal to 60 degrees. Okay. So 180 minus 120 equal to 60 degrees. And the angle between reaction force R5 and W is 90 plus theta equal to 150 degrees. And the angle between reaction force R6 and W is 90 plus theta. That one value equal to 150 degrees. Okay. So already we know that from Lamy's equation, force divided by sine of the angle between other 2 forces. Okay, force is directly proportional to the sine of the angle between other 2 forces. So here the force is R6 and the opposite angle is 90 plus theta. So R6 divided by sine of 90 plus theta. In similar way, force 2000 newtons divided by opposite angle 180 minus 2 theta. Okay, sine 2000 divided by sine 180 minus 2 theta. And third force is R5, R5 divided by sine 90 plus theta. Okay. Now you have to consider these 2 equations. Okay. You have to consider these 2 equations for determining the value of R6. R6, now apply cross multiplication for this equation. R6 equal to reaction force R6 equal to 1154.7 newtons. Okay. Now you have to consider these two equations for determining the value of R5. Okay. From these two equations, you can get the value of R5. Now apply cross multiplication. R5 reaction force R5 equal to 1154.70 newtons. Okay. So here the reaction force R5 and R6 both are equal. Okay. That value equal to 1154.70 newtons. Okay. So from this cylinder, you got two reaction forces R5 and R6. In similar way, consider free body diagram of a bottom cylinder A. Cylinder A. In second case, you have to consider this cylinder. Okay, there are four forces, so we can't apply Lamy's theorem. Okay, for three forces only, we have to use Lamy's theorem. Okay, here for cylinder A, there are four forces acting on a point A. So you have to consider a free body diagram of a cylinder A. R2 force and R1 force, W, sulfate W equal to 1000, and reaction force R6. Already we know the value of reaction force R6. From case 1, we got the value of reaction force R6 equal to 1154.70. Okay. After that, you have to convert this reaction force R6 into horizontal and vertical component. Okay. So here R1 is the vertical upward action force, R2 is the horizontal rightward force, and W equal to 1000 newtons vertical downward force. Now this inclined force lies in first quadrant. So you have to convert this inclined force into horizontal and vertical component. This reaction force makes an angle theta with respect to horizontal. So you have to consider this horizontal component as adjacent side. For adjacent side, you have to consider cos theta. So R6 cos theta is the x component. In similar way, the y component is R6 sin theta. Okay. Now you have to resolve all the forces along the vertical axis. Okay, here the theta value equal to 60 degrees. Okay. So resolve all the forces along the vertical axis. There are three forces. Okay, there are three forces acting on vertical axis. For upward action, you have to consider positive sign. For downward action, you have to consider negative sign. So plus R1 minus W minus R6 sin theta equal to 0. Okay. Now from this equation, you have to substitute the value of R6 and W value. You can get the value of reaction force R1. Okay, R1 reaction force R1 equal to 2000 newtons. Okay. In similar way, you have to resolve all the forces along the horizontal axis. There are two forces acting on horizontal axis. So sum of all horizontal forces equal to 0. For right side direction force, you have to consider positive sign. For left side direction force, you have to consider negative sign. Okay. Plus R2 minus R6 cos theta equal to 0. Okay. So from this equation, you can get the value of reaction force R2. Okay. You have to substitute the value of R6. R6 equal to 1154.70. Okay. So R2 equal to 577.35 newtons. Okay. Reaction force R1 equal to 2000 newtons. Reaction force R2 equal to 577.35 newtons. Okay. From this cylinder A, we got two reaction forces R1 and R2. Okay. Now in third case, you have to consider reaction force. This is the third case. In third case, you have to consider free body diagram of a cylinder B. Now you have to consider this cylinder. Okay. For determine the value of reaction force R4 and R3. Okay. This reaction force is R3. This reaction force is R4. Here for cylinder B also there are 4 forces. So don't use Lamy's theorem. Okay. Consider this cylinder B as it is. Okay. Now this is the reaction R3. This reaction is R4, and this one is the self weight W, and this one is reaction force R5. Okay. Now you have to convert this diagram into horizontal and vertical forces diagram. R3 horizontal force, R4 vertical force, and W vertical downward force. Now you have to convert this inclined force R5 into horizontal and vertical component. This reaction force R5 lies in second quadrant. Okay, so this reaction force R5 makes an angle theta with respect to horizontal. So for adjacent sides you have to consider cos theta. So R5 cos theta. For opposite sides you have to consider sin theta, R5 sin theta. Okay, so these are the 5 forces. Okay, from these 5 forces you have to determine the value of R3 and R4. Here R5 value is 1154.70. Okay, from case 1 we got the value of R5. Okay, now resolve all the forces along the vertical axis. There are 3 forces acting on vertical axis. So for upward action you have to consider positive sign. For downward action you have to consider minus sign. So plus R4 minus W minus R5 sin theta. Okay, so now substitute the value of R5 and W. Okay, we got the value of reaction force R4. R4 equal to 2000 newtons. Okay, reaction force R4 equal to 2000 newtons. Now resolve all the forces along the horizontal axis. Okay, R5 cos theta and R3. There are 2 forces acting on horizontal axis. For right side action, you have to consider positive sign. For left side action, you have to consider negative sign. So R5 cos theta minus R3 equal to 0. Now substitute the value of R5 and theta value in this equation. You can get the value of R3. Reaction force R3 equal to 577.35 newtons. Okay. From this case 3, we got 2 reaction forces R3 and R4. Okay. So this is from this diagram we can observe there are 6 contact points. So you have to calculate 6 reaction forces. Okay. So I got 6 reaction forces from 3 cases. From this cylinder C, I got R5 and R6 forces. Okay. From cylinder A, we got R1 and R2 reaction forces. From cylinder B, we got R3 and R4 reaction forces. So the following are the answers for this problem. R1 reaction force R1 equal to 2000 newtons, R2 equal to 577.35 newtons. Okay, and R3 force is equal to R2, that value equal to 577.35 newtons, and reaction force R4 equal to R1. Okay, that value equal to 2000, and reaction force R5 and R6 both are equal. Okay, reaction force R5 equal to 1154.70 and reaction force R6 equal to 1154.70. Okay, so these are all are the answers for this problem. Okay, there are 6 contact points, so you have to determine 6 reaction forces. Okay, so these all are the answers for this problem. Okay, in next class I will explain more examples on this type. Okay,